Okay, I want to talk about the pre-image in a Bitcoin transaction. You may have heard the term, um, and it's basically, well, I have it up here, the raw structured data that gets signed. So the pre-image never goes on the blockchain. In fact, because it's what we sign, I would say the reason it doesn't go on the blockchain is because that's the verification piece. So the verification engine has to go grab all the parts that you sign to verify the signature. So you'll see it's actually pretty complicated. And the reason that I'm doing this video is to teach others what I had to go and learn, because I had a really hard time signing a custom transaction, a custom script that I wrote. So a non-standard script. So when you look on what's on chain, sometimes you see non-standard output or non-standard script, I think it says. And it's those that are a little bit trickier, and it lots of times comes down to not getting the pre-image right. And that's what I found for myself. So I think an analogy might be interesting to help kind of wrap your brain around this. So imagine you're at a restaurant and they have a way to deliver a check to you. That means, basically your bill, uh, so that every party can pay separately. And so the check has each party sign their part. So if I'm person one and I'm looking at the check and I have to verify, I have to see that what I had on there and how much it was is on there. But I also have to go and I have to scan and see what everybody else's order was. And then I have to go and see what the total was and what the tip was. So those would be the outputs. And I have to include all of that in my signature. So not only my stuff, but parts of everybody else's, so that the whole check gets signed. So the whole transaction gets signed. So each input, and in Bitcoin, you can have multiple inputs in every transaction. So each of those inputs gets a pre-image. All right, so now I will go over the parts. I have this structured in sections. I haven't seen anybody really teach it this way, but this is how my brain understands it. So, because in a pre-image, you have your per input items. So that means so for this individual input, I need to know these specific things. But like I said, that check analogy at the restaurant, you also have to scan and know all of the other inputs and then all of the outputs. So that's how we're going to go about looking at this. So let's look at the first section, which is, I'm going to move this down here. All right. So the first section is the same for every input. So every input is going to have these same items. And it's basically three things. It is a digest, which means a hashed. It's a double hash actually of every other input's index and the TXID that it came from. So a digest of this for every transaction. I'm sorry, every input. And then you need a digest of every nSequence. We don't need to worry about what that is, but it's most of the time it's going to be the same for every single input. But again, for each input, however many you have. And then we need a digest of the outputs. And it's a little bit different for the outputs. So you need the amount, so the number of satoshis, and you need you need the script. So you need the script code that's associated with it. And I think there's one other thing. Let me check my notes. No, that might be it. Okay. So it's the third. So we have 3 digests. And that's so encompassing all of the inputs and all of the outputs. And again, we're talking about one pre-image here for one input. So now let's do the per input section. So for every input, you need, again, you need the hold on, the TXID and the index where it was in that transaction. And you need the amount. How many satoshis was it? And you need the script code for this. So it's some version of the locking script from that transaction. And I say some version, it's a little bit complicated, and that's where I ran into some troubles. You also need the nSequence. You need the TXID, you need the index, you need the amount, you need the script code, and you need the nSequence. Okay, and now the tail. So the tail, let's see if I can get that out of the way. The tail is the same for every input, and for that you just need the lock time. And most of the time, the lock time is going to be now. And then you need the sighash type. So for what I just described here, this is sighash all. You also have the fork ID on there, but that's always going to be the same. So the sighash all is only one sighash type, but it's going to be the vast majority of transactions you see on Bitcoin. It's a whole other thing that I won't get into, but I think the important piece about it, what it is that you're signing. So the pre-image, so this pre-image is what you're putting your signature to. And you need a signature on every input. And the items that you are signing are what I just went over for the sighash all. So for every input, you're going to have all of these items, and they have to be in a certain order and formatted a certain way. I mean, that's what software does for you, but sometimes when you're a builder, you have to know these things if you're doing things that are out of the ordinary. So that's why understanding this pre-image is important. So you might have heard this term dir encoded signature. It's referring to the ECDSA signature that you get after using your private key to sign the pre-image. So I think that's it. I'm sure people have a bunch of questions on this. It's very complicated. I wish it were not. But I'm now very happy that I understand this deeply and I successfully spent that custom output. So that was really fun. Anyway, hope this was helpful and see you next time.